Imagine a virus so ingenious, so stealthy, that even the brightest minds in science have yet to conquer it completely. An invisible enemy that for over 30 years has defied every attempt to defeat it. Why don't we have an HIV vaccine yet, while science was able to create multiple COVID-19 vaccines in record time? What makes HIV such a uniquely insurmountable challenge? Get ready, because what you're about to discover will change the way you view science, evolution, and the very concept of combating diseases. Why, after all this time, do we still not have a vaccine for HIV? HIV, the invisible and relentless cause of AIDS, carries with it a history of challenges and resilience. It is transmitted through 4 primary routes: unprotected sexual contact, by far the most common, sharing or accidental exposure to infected needles or sharp objects, transfusions of contaminated blood, or from mother to child during childbirth or even through breastfeeding. In the early 1980s, when the AIDS epidemic began devastating communities, an HIV diagnosis was essentially a death sentence. The outcome was swift and unforgiving, with most patients surviving only a few years or even months after diagnosis. It was a time of fear and uncertainty, as little was known about this invisible enemy that was changing the world. But science, as always, refused to surrender. Decades of research have transformed that grim reality. Today, thanks to highly effective treatments, people living with HIV can achieve an undetectable viral load. This not only prevents the transmission of the virus, but also allows them to live healthy, long, and dignified lives. It is a monumental achievement in medical history, but let's not forget, HIV is still there, hidden, silently lingering, and therein lies the great dilemma. Despite all the progress, the virus remains in the body like a ghost that cannot be exorcised. This is why the quest for a vaccine is so critical, a definitive solution that could prevent infections and bring an end to the epidemic once and for all. Yet, even after more than 4 decades of relentless effort, this vaccine remains out of reach. With every promising breakthrough, new obstacles arise. At every step forward, HIV reveals another facet of its ingenious strategy. Creating a vaccine becomes even more complicated due to technical and financial challenges, which we'll delve into later. But why is HIV so unique? Why, in a world where vaccines for pandemics have been developed at record speeds, does this virus remain unbeatable? Number 1. A direct attack on the body's defenses. Imagine an enemy so cunning that when it invades a fortress, it doesn't just fight the soldiers, it turns them into allies. This is precisely what HIV does. It infects CD4 plus T cells, the generals of our immune system, responsible for orchestrating the body's defense against invaders like bacteria and viruses. By attacking these cells, HIV silences the immune system's command center right when it's needed most. The result is devastating. Over time, these infected cells die, leaving the body vulnerable to diseases and infections that would normally be easy to control. But the virus doesn't stop there. This insidious trick makes developing vaccines even more challenging. How can we create an effective defense when the virus turns the body's primary protector into its hostage? Number 2. The unpredictable dance of mutations. Now imagine another masterstroke by HIV. Every time the virus replicates within cells, it makes tiny errors while copying its genetic material. These errors, known as mutations, keep HIV in a constant state of evolution. While other viruses, like the coronavirus, accumulate 2 to 3 mutations per month, HIV operates on a completely different level, racking up to 4 times as many mutations in the same period. This rapid pace creates an immense variety of virus versions, making it a constantly moving target. For traditional vaccines, which rely on targeting a specific version of the virus, this variability is a nightmare. The immunity generated can quickly become ineffective as HIV evolves and creates disguises to evade the immune system. Developing a universal vaccine capable of combating all HIV subtypes is undoubtedly one of the most formidable challenges in the history of science. And don't think this is unique to HIV. Even though the coronavirus mutates at a slower rate, its high circulation still poses a significant risk. The more a virus spreads, the greater the chance of new variants emerging that could evade existing vaccines. But that's a topic for another video. Want to learn more about it? Let us know in the comments. Number 3. HIV's perfect hideout. HIV doesn't just invade the body's defenses, it hides within CD4+ T cells, integrating itself into their DNA. Safely tucked away in this invisible sanctuary, it lies dormant, undetected by the immune system and even by current treatments. It can stay hidden for months, years, or even decades without showing any signs of its presence. This ability to disappear makes HIV a master of patience and a nightmare for science. While hidden, it not only evades destruction, but also challenges any immune response induced by vaccines. After all, how do you fight something you can't even find? But that's not all. This characteristic presents another massive obstacle. If HIV can remain dormant for so long, how can scientists quickly determine if a vaccine is effective? Unlike respiratory diseases like COVID-19, which show symptoms just days after infection, HIV requires years of observation during clinical trials to confirm whether a vaccine truly prevents disease progression. This extended timeline makes developing vaccines against HIV an even slower process. However, science is fighting back with new strategies. Researchers are testing substances designed to flush HIV out of its hiding places. The idea is straightforward. Force the virus out of its comfort zone and then attack it with a combination of therapies, including vaccines. While promising, this approach is still in its early stages. Number 4. The lack of natural immunity to HIV. Unlike diseases such as measles or the flu, where the body can recover and develop natural immunity, HIV is relentless. It gives no quarter. Once the virus enters the body, it becomes a permanent resident. The human immune system simply cannot eliminate it, and that makes developing a vaccine profoundly challenging. Vaccines typically mimic the body's natural immune response, enhancing it to fight off infections more efficiently. But when it comes to HIV, this natural response doesn't even exist. How do we create an artificial defense for something evolution itself hasn't figured out how to combat? Still, science has uncovered a valuable clue: the so-called elite controllers. These rare individuals possess a unique ability to control HIV without the need for medication. While the virus remains in their bodies, it doesn't progress. Studies suggest that this remarkable resilience is linked to specific genetic traits, such as the HLA-57 gene, which helps the immune system mount a more effective response. But don't go anywhere just yet. Beyond these biological challenges, there are also technical and scientific hurdles that make this battle even more complex. Want to learn more? Keep watching because the best is yet to come. But before we continue, you can support the channel in a simple way without spending anything extra. Just click on our Amazon link in the description before making any purchase. This way, the channel receives a small commission at no additional cost to you. Thank you so much for helping keep this content alive. Number 5. Vaccine technologies and the challenge of HIV. For decades, science tried to use traditional vaccine strategies to fight HIV. But this virus, with its nearly unmatched complexity, quickly proved that the old rules wouldn't be enough. Inactivated virus vaccines, which use killed pathogens to stimulate the immune system, don't work well against HIV. As counterintuitive as it may seem, the inactivated virus cannot generate a robust protective immune response. It simply can't teach the body how to defend itself effectively. And what about attenuated virus vaccines? While they work well against many diseases, they carry a dangerous risk when it comes to HIV. This highly adaptable virus could potentially regain its virulence and cause the very disease it's meant to prevent. It's simply not worth the risk. This forced science to take a bold leap forward, turning to more modern and innovative technologies. Molecular biology and genetic engineering had to evolve first, enabling the development of new platforms. Today, we are entering a new era led by technologies like messenger RNA and viral vectors. The COVID-19 pandemic accelerated advances that are now directly benefiting the fight against HIV. mRNA vaccines, which saved millions during the pandemic, are being adapted to tackle this historic challenge. Companies like Moderna have already begun clinical trials for an HIV vaccine using this technology. mRNA acts as a messenger, teaching the immune system to recognize critical parts of the virus without exposing the body to the entire pathogen. It can be programmed with precision, allowing scientists to quickly adapt vaccines to different variants, an essential feature when dealing with a virus as mutable as HIV. But it's not just mRNA. Viral vector vaccines, which use harmless viruses to deliver HIV genetic information into the body, are also making progress. One of the most ambitious recent efforts was the Mosaico study, led by Janssen, which reached phase 3 trials in multiple countries. This innovative research combined two approaches. The first used a viral vector, an adenovirus modified to carry HIV genetic fragments, to teach the immune system how to recognize the virus. The second employed a protein subunit vaccine made of synthetic proteins mimicking parts of HIV, designed to represent various subtypes of the virus. The goal was simple yet bold, to induce a broad and effective immune response against the many HIV subtypes, reducing the chances of immune escape. But despite its ingenuity, the results released in January 2023 brought disappointing news. While the vaccine was safe, it did not provide effective protection against HIV infection, leading to the discontinuation of the study. However, science did not retreat. On the contrary, every failure brings invaluable lessons, and now we are witnessing the emergence of a new generation of promising technologies. Messenger RNA-based vaccines, which revolutionized the fight against COVID-19, are being adapted to tackle HIV. Companies like Moderna, in partnership with IAVI, have begun clinical trials of a vaccine using mRNA to stimulate the production of broadly neutralizing antibodies, powerful weapons capable of combating multiple subtypes of HIV. In addition, long-acting therapies are opening new doors. In 2024, a significant breakthrough was announced. Lenacapavir, a semi-annual injectable antiretroviral, demonstrated 100% efficacy in preventing HIV-1 in clinical trials. While not a vaccine, this approach marks a milestone in controlling HIV infection. The fight against HIV reminds us that science is a marathon, not a sprint. Every study, every trial, every advancement, even those that fall short, brings us one step closer to a definitive solution. And now, more than ever, we are at a pivotal moment. The combination of cutting-edge technologies like mRNA and innovative approaches such as long-acting therapies is shaping a future where the eradication of HIV could finally become a reality. If, like us, you believe in the power of science and want to continue following this historic journey, leave a like, share this video, and support the channel. And remember, you can directly help keep this kind of content alive by making your Amazon purchases through the links in the description. It's quick, simple, and costs you nothing extra. And if you want to stay prepared for the future, pay attention. Another global threat is on the horizon. Want to learn more about the potential pandemic caused by the H5N1 virus? Click the video at the end to find out what's happening and how we can face it. You won't want to miss this discussion.